Good morning, guys. Hope you're doing fine today. Today we're going to start a new teaching strategy called Flip the Classroom, by which you will go home, listen to my lesson, and hope you enjoy it, and come to class understanding the lesson and applying what you understood. So in other words, instead of giving you a homework home, you're gonna do your homework in the class, and I will be watching you discussing the homework together in groups and solving it together. And of course, I'll be there to help you and assist you in anything you need. Okay, our first trial will be lesson 3.3, which is our third lesson for this term. The title of this lesson is Rate of Change and Slope. Now, what do we mean by rate of change? If you divide the word into parts, you will discover, so if you divide the word into parts, you will notice that it's rate. So rate, it means part of a ratio, and that's why the rate of change is in fact a ratio. Thus, it's a comparison between two different values, but this comparison is not a fraction, it's just a ratio, okay? So the ratio or rate of change is a ratio that describes on average how much one quantity changes with respect to a change in another quantity. Okay, so how much a quantity changes with respect to another. Now the comparison, when we talk about rate of change, is between the independent and dependent values. If you still remember, we took it last year, and we said whenever something depends on another thing, we call it dependent variable. So for example, the variable y, it depends totally on the values of x. So y value depends totally on x value. So that's why we call the values of y dependent variables. While the values of x are independent and they don't care what is the value of y. That's why we usually choose x values from our mind, or we choose them in any way we want, all right? So precisely the rate of change is equal to the change in y divided by change of x. What does it mean, change of y? When we talk about change, let's have an example. Change, for example, like the change in weight, okay? So the change in weight, let's say I'm on a diet plan and my weight was 59 kilograms, and after 1 month I lost 3 kilograms. So my weight now is 56, okay? Now of course I didn't lose 3 kilograms all at once. The 3 kilograms were lost gradually. So if I want to write down that in a table, it would be like at time 0, my weight was 59. Then after, let's say, 2 weeks, it became 57. Then after a month, it became 56. So in fact, you can see that the values change gradually. But all I care about is the final change, like how many kilograms I lost in this whole process. So I was initially 59 kilograms and now I'm 56. Even though after 2 weeks I was 57, but you don't care about the values here in the middle. You care about the final value. So in other words, we care about the maximum value and the least value. That's what has happened in the table, in the real world example, entertainment. So in this table, they were talking about a number of computer games and total cost. So it's comparison between both. The first value was two computer games of a value $78, and then 4 of a value 156, then 6 of a value 234. Now when we want to calculate the rate of change, we don't care about the value in the middle, the 4 and 156. We care about the minimum and the maximum. So the change in y will be subtracting 78 from 234. So subtracting the minimum from the maximum. And the same has happened to the change in x, okay? Now, why we put change of y before change of x, or why we put it in the upper part? It's because the definition says that if x is the independent variable and y is the dependent, we usually put the y values in the upper part of the ratio and the x values in the lower part, okay? At the end, it doesn't matter when it's a rate where you are placing the values. What matters is the comparison and the way we read it. For example, in the entertainment part, we can read it as a change in y is the change in cost, and the change in x is in fact the change in number of games. So if you find out the maximum minus the minimum, it will be 78 over 2. But we keep on simplifying the final answer, like in all the problems of math. We do simplify to reach the final answer 39 over 1. Now, if you want to analyze this answer, you have to analyze it as 39 refers to the change in cost. So it's $39 per or divided by or over a change in number of games, which is 1. So it means that each one game is of $39 cost. Okay? So that is what we call it unit rate. Okay? Now, if we want to move to the second example, another example talking about area of tiled surface in inches square and number of floor tiles. So in this table, if we want to calculate the rate of change, again we do calculate the difference between the y and x, and the difference will be between the maximum value on y and the minimum value, which is 144 minus 48, divided by the number of floor tiles. The maximum is 9 minus 3. So if you calculate this ratio, the answer will be 16. What does it mean? 16 inches square, because 16, the upper value, it refers to the area of tiled surface, change in y, per one tile. So each tile in this arrangement is of a value 16 inches square. Okay, so that was our first part. It talked totally about rate of change and how to calculate it using a table. Again, as I told you, just care for the difference in y and the difference in y. The difference is subtracting the maximum value minus the lower value, then dividing both together, simplifying the final answer, then analyzing what does it mean, referring to the meaning of each value of this rate. That's our first objective. It was about unit rate, it was about rate of change. That's what I need you to concentrate on. Try to practice by solving 1 or 2 odd numbers from your book, so tomorrow when you come to class, you're ready enough to discuss this together and to solve more problems about it. Thank you and good luck.